This is my name. I'm teaching in the UIC this semester. So what I'm presenting is a work in progress. It's basically a section in a chapter which is a work in progress in this book on the emergence of spacetime string theory. Maybe a couple of words about the general context in which this presentation should be considered. So I'm writing a book about the notion of space-time emergence in string theory, and I'm trying to argue that the notion of space-time emergence is a multifaceted notion, is a composite notion. It's, I would say, a landscape of different notions of emergence related to each other. And as Amanda was talking before about the derivation of general relativity from string theory, I mean, to speak about emergence of GR is different, I mean, has a different meaning from speaking about emergence of compact vector dimensions, because these two ways of dealing with the issue of emergence of space-time relying on different methodologies. I mean, as Amanda was saying, the derivation of GR comes from a classical action, which is classical string action, which is quantized, and then by reimposing conformance you get quantum level, and there is a notion of change of energy scale involved. You can derive GR. Whether on the other side, the emergence of a compact dimensions rely on a notion of duality, and duality is a different methodology. So when I started to write the chapter on at the ICFT correspondence, and I came across I found a group of interesting work which I'm going to show you. I found out about a research program which had been started between 2001 and 2006, and the issue, the nature of IDS-CFT duality, talking about emergence in that context, has to do with the emergence of a higher dimensional space-time from a lower dimensional space-time. And the emergence is about the spatial dimension, which is the radius of the book. So I found several papers, several works about the possibility of having, in the context of string theory, a notion of holographic emergence of time. And I thought to have this description, this part of this, this kind of scientific papers in my book. So this is a research program that, so they try to show, to build, it's an open research program, it has not been taken into compression. They try to show how a physics with time can arise from a timeless physics. And it has not been taken into conclusion because, it has not been completed because there are many technical difficulties, and I will go over this. Also, it is a research program that branched off in different ways to attack the problem, and all these different ways try to imitate the reasoning of the kind of logic underlying the ADS-CFT duality, that, as far as I know, is the only complete non-perturbative formulation of string theory. Although it is still an incomplete program, I thought that, if it would be completed, it has two very nice features. For a philosopher of science, of course. It involves a more realistic book geometry, which is a de Sitter spacetime, and our universe is thought to have, it has been found that it has a small positive cosmological constant, and it is also considered to have an asymptotic de Sitter structure in the future. And also there is a kind of philosophical payoff, some kind of interesting philosophical reflection, because it delivers an account of how some physics with time arises from some timeless physics. And generally, this is considered a case of supervenience. And in the philosophical debate, it is presented like a case of supervenience, which is a weak notion of emergence. But So it would be interesting to have some philosophical thoughts about if this is really the case, if the kind of supervenience which is described here is the traditional philosophical one. I mean, so here. So just a few basic things about ABS-CFT. Amanda, I mean, just already introduced a lot of interesting stuff, so I don't need to say too much. I mean, as she said, a feature of the black hole entropy law is the fact that it is universal applicable, and so several attempts of understanding the microscopic origin of this law produce several varieties of insight, and all these insights culminated in the ABS-CFT correspondence. This is a very sketchy description of it. And this is a correspondence that involves a conformancy theory over Minkowski boundary and a quantum gravity theory in anti-de Sitter spacetime. And the prototypical example is something that Amanda was showing before, ABS 5 times F5. So two crucial features of this correspondence are, basically speaking, the boundary data of GFT, holographically reconstruct the radial dimension of the bulk, and the second is the boundary data of CFT holographically reconstruct the compact extra dimension S5. And for what, I mean, for the aim of this presentation, I will be focused, I mean, only on the first one, because this is a feature of ABS-CFT, which is mimicked by this new theoretical setting that tries to realize some kind of physically instantiable, no, I'm sorry. we try to reach some kind of implausible model of holographic time. I mean, they mimic the first this picture, I mean, the emergence of the radius, the holographic emergence of the radius. So maybe for some of the physicists here, part of this presentation will be boring, but I thought that before making some philosophical comments about the notion of supervenience and try to understand what do they mean when they speak about supervenience, it is interesting to reconstruct the feasible theoretical arguments of this group of physicists that can give some kind of interesting content to the philosophical reflections. And so I try to reconstruct the arguments, the way in which they try to formulate a new kind of holography. So if this is an anti-de Sitter spacetime, the boundary is a space-like infinity boundary, and the feature of ABS-CFT, which is mimicked in this new theoretical setting, is basically the way in which the boundary data encode the radial evolution of the bulk scalar field. And precisely, and the way, I mean, what kind of boundary data we are thinking here? Well, the renormalization group flow of the boundary field theory, basically the beta functions that gives the way in which the boundary coupling change with respect to the change of energy scale. And so this kind of data completely match with the radial evolution of the potential of the bulk field. I mean, I don't know if I need to give more technical detail. Of course, the bulk field and the boundary field are chosen, I mean, in a way that they are connected to each other. So you have the action of the theory inside the bulk, and you pick a solution by fixing a boundary condition, and this boundary condition is basically chosen in a way which represents the source for the operator. And so you have basically that the field on the boundary and the field in the bulk comes to know each other in the boundary. But so I don't think I mean, this is boring for the physicists and probably it's not helpful for the philosophers. So I think that it's enough to know that precisely that this is the way in which the boundary reconstructs holographically the radial evolution of the bulk inside the bulk. So trying to get an emergent time requires involving theories which have different asymptotical structure. different from the space-time involved in ABS. And the book Spacetime involved in this contest is De Sitter, and Amanda was mentioning this before, which has a symptotic structure time-like. It has a time-like infinity. So, broadly speaking, these people, it has been told that if a theory of quantum gravity exists in a De Sitter space-time, then its hypothetical dual would be a timeless quantum field theory. A kind of rather peculiar quantum field theory, and we will see something more. Basically, quantum field theory on a space-like boundary. So, first problem. Well, I would say maybe the only problem, which is a huge obstacle. Trying to embed the Sitter space-time as a solution of string theory didn't really accomplish very much so far, at least until 2011. And because there is the absence of a concrete string compactifications of the Sitter, and that makes it very hard to formulate a conjecture, and especially to testing this conjecture. But in 2001, there was this group of researchers, Strominger, and I can't pronounce his name, but Bohr and Mimic, all these people, didn't get discouraged, and
it's Minich.
I'm sorry?
It's Minich with an N.
Oh, Mimic, sorry. Yeah, sorry for the pronunciation. So, a first attempt to figure out how to deal with the situation was very interesting. So, basically, they tried to come up with some correspondence, some conjecture about the ABS-CFT correspondence that in principle didn't require any inputs from field theory. So maybe they hoped, well, maybe in the meanwhile someone will find some kind of nice concrete compactification, and then we can test this conjecture, or maybe it will turn out that some other quantum gravity theory will do the job. You don't know. So how did they do? How Strominger arrived to make this conjecture? Well, the idea was to mimic the logic underlying the ABS-CFT duality, at least those aspects of the logic underlying that duality which do not rely strictly on string theory. So, well, if you have a candidate duality, this duality, in order to mimic ABS-CFT correspondence, should at least have these two requirements. So the symmetries of the two dual theory must match, and then it should exist a dictionary for translating correlation function. And the point number 2 is basically also the source for developing some thinking about the holographic nature of the bulk radius in the ABS-CFT. Since it is the variation of the boundary field coupling that encodes the radial behavior of the bulk field. So, this is where it comes from, the radial evolution. So how did they deal with these two features? Were they able to come up with something? And I found out by studying their paper, trying to reconstruct what they say, that if my reading is correct, about the first point, well, Strominger explicitly computed the asymptotic symmetric group of the De Sitter space-time, and it came out, which is the Euclidean conformal group in the dimensions. And this computation gave information about the fact that if a quantum gravity theory in a De Sitter exists, then its hypothetical dual would be a local quantum conformal field theory on a Euclidean boundary, the boundary, which is time plus minus infinity. And this was the first, I'm here really sketching a very long paper in which he made this computation. About the second point, well, in that case, they have, it came out that the trace of the stress boundary tensor, which has a natural relation to the normalization group flow, because it's about beta functions, gives information about how the book spacetimes reacts when there is a change of metric over the boundary. And they were able to identify, in particular, a precise relation between the dilatation over the boundary and the time translation in the book. And this correspondence, this is something that we will keep in mind for later, it can be read in both directions, because it was supposed to be a one-to-one map. So this is a conjecture holographic correspondence. So it tells you how string theory in the de Sitter, if exists a quantum gravity theory in the de Sitter, this is how it would look like. But, so it wasn't still, although intriguing was dealing with this difficulty to find some kind of concrete compactification of de Sitter. To embed de Sitter as a space-time solution, as a solution in string theory. So a second way to attack the problem was keep this conjecture there, and it was developed still by Strominger a few years later, now Good Perle or something, and he uses the brains and S brains. Basically, they argue that string theory may actually produce the kind of Euclidean field theory needed by this conjecture correspondence, and I show you how, some feature of this argument. So basically, they say, okay, we now are able to, probably we are able to show that string theory can produce the CFT side of this conjecture. And then eventually, at the end of the paper, they discuss also some gravity solution produced by some specific case. And one which is interesting is the fact that one of them is the four-dimensional Einstein Maxwell gravity, which corresponds to a charge S0 brane. So let's sketch how the line of reasoning goes. So already Amanda spoke about the brain, so I don't need to say very much. They are objects in, when you have a finite, a strong coupling, they cannot be seen with coupling, but because they are very heavy, but they are not put in the theory by hand. Okay, and this was a claim that she made, and I like very much. And so here I didn't know that she was going to give details about the brain, but the brains are just, D stands for Dirichlet, for those who don't know, for the philosopher who don't know that, and 3 plus 1 dimension. There is also a different class of the brains. Now, this sentence here about SP brains is very sketchy. It's a bit more complicated than that, but let's say that SP brains are thought to be the space-like version of ordinary brains. And they have P plus 1 dimensions, but these dimensions are all spatial. There are some work which has been done to prove that these SP brains are basically the space-like version. Basically, they have a Dirichlet boundary condition, which is, in this case, obeyed by the time coupling, differently from the ordinary Dirichlet boundary condition. Now, the crucial point was to argue that, and they did it, that string theory contains these S-branes as a result of decay of unstable D-branes, which are basically D-branes with a tachyonic field. Okay, so we are now slightly moving in the context of string field theory, because we are in a strong coupling. They have these unstable D-branes are brane with tachyonic field, whose potential resemble a double well. And I show you, for those who don't know, what a double well is. In this sense, and now I'm saying something, S-brane are thought to be time-like king solitonic solutions. So who took a class of quantum field theory knows what this kind of solution is. So, but I thought I may say something to show what does it mean. So they say, okay, as brains are this kind of solution, they exist in string theory, and the Euclidean field theory involved in the CFT conjecture seems to be naturally related to these space-like brains. Okay, but what does it mean that a space-like, I mean, at least when weeks ago, well, no, 2 months ago, I started, what does it mean to say that a brain is space-like? Try to figure out in a more concrete way to visualize. Well, understanding what time-like King solution means, clarifying what sense they are space-like. And so I came up, I mean, reading my notes of quantum field theory class, I came up with a nice way to put it is just to show an example of what a time King solution is. And I apologize for the change of format, but LaTeX didn't work with my slides, so I had to take a picture of my notes in PDF. So far so good? Okay. This is something that many of you probably know. I don't know how many people do not have any idea of what the King solution is, but so basically, or maybe this is more clear. But basically, I mean, this is an example of King solution in an ordinary field 4 theory, 1 plus 1 dimension, and this is more easy to understand. And then we just have to generalize this to the brains. So it's not, I mean, after all, it's string field theory, so quantum field theory. So there is a Lagrangian, and this is the potential, which is a double potential, and there are with 2 vacua, a negative and a positive vacua, and so basically this is how the phi is the solution. So this S brain is basically playing out the role of phi here. It's the solution that interpolates the 2 vacua. So if you look, I'm not specifying here on the right side of this slide. I'm not saying what X is, whether it is space or time. But what you have is that whatever X is, imagine that X is space. So imagine that your unstable field is sitting on the top, and it's very unstable. And so it roll off on the right, and so it goes and it just rolls down. It emits radiation, and it's just sit on the positive vacuum. If you take the reverse, going to x minus infinite, it goes to minus phi 0, which is the negative vacuum. If you take your movie from minus infinite to plus infinite, you have the situation, this evolution, and let's assume now the x is space. You have this evolution in which there is a field sitting on the top of the vacuum, and there is some kind of incoming radiation that conspires to excite the field. The field goes to the top, and then it is so excited that it has a lot of energy. It goes on the right-hand side to stop on the second vacuum, on the positive vacuum. So if X is spatial, this solution is called a space-like King solution. And it is thought that in string theory, D2 brains, if you have a D3 brains, an unstable D3 brains, which has this potential configuration, the spatial-like King solution gives produce a D2 brains, which is this function here. But if you take X being time, now you have that this is a time-like King solution, solitonic solution. And the solution is basically interpolating in time the 2 vacua. So the first time I said, yeah, why is it space-like? Well, looking at this, you understand what it means to be space-like, because it's very, very strictly confined in time, if you consider X to be the time. And so they are considered to be a space-like hypersurfaces, which live just in a moment of time. Of course, this is an idealization because they have some kind of thickness which is connected to the velocity of decay of the unstable brane. So, but this is why they think that these solutions, which are admitted, which are produced in string theory, are space-like. So look at the graph. Does it help? Yeah. Okay. Okay. So coming back to where? Okay. So back to the conjecture of the SCFT. Basically, Strominger and Guttell showed that if you have, an unstable D3 brane with a tachyonic field, the solution, the double potential, is this S2 space-like version, space-like brane, which seems to basically fits very well in the conjecture of correspondence. So basically, in the SCFT correspondence, the D-brane field theory holographically encoded a spatial dimension. Since string theory produced the CFT side of the conjecture, and I'm not going into the specific. Amanda was talking about the non-unitarity of this theory. I'm being very general here. Since string theory produces the CFT side of the conjecture, seems to, by using an analogy with the SCFT, you have that the S-brane field theory should holographically reconstruct this time and time dimension. How does it work? Well, if you know that, as Amanda was saying before, so in the SCFT there was this, what motivated the correspondence was the work of Polchinski in 1990. If you have, the idea was to look at a stack of ND branes. Well, Baldacena then made the conjecture. So to look to the stack of ND branes by using two different perspectives. From the perspective of the weak coupling, and then in that kind of perspective, open string dominates the scenario. And there is a certain low energy limit that produces the SUN Young-Mills theory over the boundary. But then, underlying this idea of Polchinski, there was a previous idea of Polchinski in 1986 in which he found this duality between open and closed string. And so basically, since if you then move to how closed string come into the story, well, if you look to the stack of ND brane in a regime of strong coupling, the D branes, in the case of the SCFT, have a gravitational effect. They couple with the closed string, and so you have a theory, a string theory with gravity. And so it came out that there is a certain weak coupling in which the SUN Young-Mills theory is by itself the closed string theory with gravity. And so they basically thought that they could do the same with this time an N stack of S branes by using these two different perspectives. And now, the point is, did they find really a quantum gravity theory on the sitter? So they found one side of the conjecture of correspondence. Well, I think that at least as far as I know, the two solutions that I found, so they found two interesting solutions, particularly the first solution, which is, well, it is, so they basically compute the gravity theory produced by this, by the S brane, which in this case is an S0 brane, so a one-dimensional space-like line, or a one-dimensional space-like manifold. And they found, in a way, it takes a lot of computation. I just didn't, and I'm not willing to give you the account of how they work with that. They found that it produced a bulk with an Einstein-Maxwell gravity theory. And so and then there's this other case in which they work with an S5 brain field theory, and they find a bosonic action supergravity theory in random dimension. And they also thought that the first solution, composite, gives some kind of it is useful for thinking in terms of some possible compactification of the sector. But this is still really very open. This is really very open issue, very open problem, very much work in progress. So far, so this is basically, I don't know if you have questions or if you want me to come back on something. Yeah.
I think it was very clear. At one point, a few years ago, I wrote a paper on S-brains, and this is in accord with what I knew. So.
Okay, cool, thanks. Yeah, it's very sketchy though, because there would be more things to say about the S-brain and S-B brains, because it's not so trivial that they are identified, but it would have been. So, well, we see, this is interesting. There is a start to instantiate this kind of correspondence. It has a lot of interesting philosophical consequences, at least for a philosopher. Why is that? Well, as we said initially, the sector space is a more realistic model. It's a cosmological model. It's a more realistic model if we think to our universe. And so it might be, to have progresses in this program of research in physics, it might really have a huge impact on how we should think about time in our universe. And also there is this notion of, here I wrote in the philosophical definition of supervenience. So, and this in some sense connects with what I think Daniele and Amanda were discussing before. So I'm thinking to positions like Dean Wrigley's paper. There is a wonderful paper which has been published in 2012, and then also Nicholas Seth speaking about how should we think in terms of emergence of supervenience. And as I said initially at my talk, string theory really gives a landscape of definition about emergence. Here I'm using the word supervenience because supervenience is a kind of weaker notion with respect to emergence. Emergence sometimes can have some kind of strong ontological meaning in which it introduces a notion of asymmetry. There is something which is more fundamental from which this other theory arises. And as we've seen in what I showed you before, even in this context, in this the SCFT correspondence, there is nothing in the mathematics that justify introducing this asymmetry in talking about the relation between the two theories. And so there must be some kind of metaphysical assumption in addition to that. Maybe there might be a talk about strong emergence should be at least, let's say, grounded on some speculation about, okay, let's see the number of degrees of freedom. If there is a way to identify the degrees of freedom on both sides to see what is the theory which has less degrees of freedom, and maybe in that case a notion of strong emergence would be grounded. But emergence is not only ontological emergence, it can be something weaker, and it can be a kind of supervenience, exactly in the way in which, for example, in the debate in philosophy of mind, when they say the state of mind supervenience on the brain state. And is this the case? Dean Wrigley speaks about supervenience in the context of ADS-CFT correspondence, but he also says, look, the ADS-CFT correspondence is not a genuine philosophical case of supervenience, because what you have there is higher space emerging or supervening. I tend to switch because I'm thinking to the weaker definition of emergence. You have in higher dimensional space emerging from a lower dimensional space. So, and this makes this the notion of novelty a bit weaker because still there is space down there. So, in which sense, I mean, we can think about, I mean, the notion of novelty introduces quite late. And I thought that, that this kind of work, which has been made by this theoretical physicist, could introduce instead a notion of stronger supervenience. Because really, you have here, I mean, if they will find a way to instantiate in some concrete physical case, I mean, in a way more, in a way which is more concrete, this kind of correspondence, you really would have some kind of physics in time and emerging from something with no time. And this introduces a notion of novel consequence, which is much stronger than that introduced by the ADS-CFT correspondence. But again, I still have some problem here with the notion of supervenience. And because if you look at the definition of supervenience in the traditional philosophical way, and here philosophers know what I'm talking about, this is the canonical definition taken by the Stanford Encyclopedia, so it's the one, I mean, so you have the property A, supervening properties B, just in case there cannot be an A difference without a B difference. And this is true, I mean, if you read the work, I mean, let's just think to the emergence of the SCFT correspondence. It is true that you cannot have two different temporal evolution in the book without having two different energy energy scales on the boundary. But this is also true in the other way around, because as I said before, it's a one-to-one correspondence. So why are these people using the word supervenience? I'm not saying that it is forbidden, but I think that something should be said more. I mean, to at least clarify that maybe here the notion is not used in the traditional philosophical sense. And maybe here the notion of supervenience is more related to the fact that the kind of description of the world in the dual theory, let's say the dual theory that contains time, introduce a strong, I mean, an incommensurable description of reality, because it's a description which contains time, and this is incommensurable. It is deeply different from a phenomenological point of view from the one, I mean, on the CFT side. So maybe there should be, I mean, there is room here to develop a notion of supervenience which is not, which doesn't match completely with the traditional. Am I running out?
5 minutes, yeah.
I'm sorry.
That's right.
Sorry.
That's fine.
I don't know, I saw someone raising their hand, I don't remember. Oh, yeah.
Go ahead.
Oh yeah, so I guess I just wanted to kind of ask what was exactly what your problem was with this notion of supervenience, right? So the definition of supervenience is just what it is, right?
Exactly.
Issue with the definition.
My problem was
with respect to some end or other, right?
Yeah.
So if we're able to say that the two structures in question each supervenes on the other, why there might be lots of things that will supervene on each other, lots of.
Oh, they don't think they both supervene on each other. They think that the physics with time supervene on the physics without time. And so the people usually tend to read this correspondence just in one direction. Right. And I'm claiming that there is nothing in the mathematics involved of this correspondence that justify picking just one direction, unless you make some metaphysical assumption, or unless you find some kind of piece of physics that tells you that, I don't know, the boundary theory has less degrees of freedom than the book, but this is still here.
Okay, so it may be that the two both supervene on one another, but maybe somebody wants to say that one of them is nevertheless more fundamental. And if so, that would just be a kind of manifestation of this kind of increasingly widespread opinion that modal concepts are too kind of close range to capture accidental local networks.
Yeah, maybe so you say maybe this is just being a duality, that's the problem, right? Also then was rising. So, but being supervenient to each other means they are physically equivalent.
Oh.
Maybe I'm not, but I think you're right. I think I've not been enough clear. So my problem is that when I've been studying this case of, let's say, emergence of time from timeless setting, I was hoping to find something different from the basic structure of the SCFT, because the problem with the SCFT, it is a duality and it is a one-to-one manner. I thought maybe in this case I will find out why. I will find some feature in the mathematical, physical reasoning that will justify to use supervenance just in one sense. But it came out that it is a duality. If it is, there are just two concrete examples of this duality. But, it is a duality. So, my problem is, if you say that one side is supervenient on the other and vice versa, you're just saying the two are physically equivalent. So talking about supervenience doesn't apply.
It just satisfies the definition, though.
Yeah, but what I was thinking is that if you, reading in two directions, it undermine the thinking in terms of fundamentality.
Yeah.
And the problem is, yeah, you can do this, and I think that many people do this, but then we should clarify that we are using the notion of supervenience in a quite peculiar way, which is not very traditional, because, let's think, so in the concrete example, you have that it is not the case that two different temporal evolution can be different without being a difference of energy scale, but it is also true in the other way around. So, I'm thinking to the debate in philosophy of mind, for example, right? So the state of pain, you have a supervenience of mental state on brain state, but in that case, you have that a mental state can be instantiated by the brain in two different parts, and there is the famous example of pain, for example. And this it's not what happens in this correspondence.
Yeah, sure, but all I'm saying is if the each property supervenes on the other, that in itself only tells you that the two properties supervene on the other, right? If you want to make a claim that shows that they're equally fundamental, or that shows that they're physically equivalent, there's a big philosophical project in showing that supervenience and, say, physical equivalence or fundamentality are just coextensive relations, and most people think that they aren't.
But even theoretical physicists think about fundamentality differently than we used to be. When I was an undergraduate, I was taught that the gauge principle was the thing that you used to write down the Lagrangian of the standard model. We now think of gauge symmetry as a redundancy of description.
I was just wondering if you say properties A and properties B supervene each other. How does that not imply physical equivalence? Because the equivalence classes of all the things that have the same properties A is exactly the same as the equivalence classes of all the things with certain properties B, right?
I think, so you're saying that this definition will imply the equivalence between property A and property B? What kind of equivalence are you thinking?
Well,
because this is very generic. So I was thinking to the physical equivalence. So when I say physical equivalence in the context I was describing before, I'm saying that these two theories have the same physical content. The expectation values of the operators, they match. There is a dictionary of translating the transition function and so on. So this is the kind of equivalence I'm thinking about. Mm-hmm. So, I don't see how you can,
I just meant said theoretically, I guess. Like if you look at the set of those things which all have the same property A and divide your whole space into those equivalence classes, then if properties A and property B supervene each other, then those sets of equivalence classes are the same.
Yes.
Right.
supervening each other is not supervenience. It produces another kind of theoretical relation, which is equivalent, duality.
Okay.
That's what I...
Yeah.
But, I mean,
Sorry.
I'm sure this is, I mentioned the way in which I think that somewhere, for example, the paper of Dean, there is some consideration about, it's not an entirely new idea. It's something that came out, but Dean has something like that in his paper.
Okay, so we're out of time. Thank you very much.